Hey, Algebra 1, Mr. Catlin here will help with your Lesson 12 cool down. We're graphing standard forms of these quadratic equations. And we're just kind of making some matches here on this problem. And we've got three graphs, A, B, and C. And we've got three equations, quadratic functions, actually, that they've written, f of x, g of x, and h of x, defined as you see there. And our job for number one is to match each equation to a graph that represents it, explaining how you knew. All right, so what we're going to do is match them up here. Let me use a different color. Let's use red. So F. Well, F is a positive coefficient with a -4 constant. So this -4 constant is going to put me with a y-intercept of -4. So -4 would be this one. So I'm going to match that one up with B. And my reasoning is the y-intercept equals -4. That's why I chose that. All right, let's do the next one. 1 minus x squared. Well, this one has a y-intercept of 1 because that's its constant. And a negative x squared, so it should be opening downward. So let's see, g of x is going to be the one opening downward that crosses at 1, which would be right there because there's 2 and there's 0. So this one would match with C. And I'm going to write down because the y-intercept is equal to 1. And that means the process of elimination, this must be A, and its y-intercept is 4, which makes sense. Y-intercept equals 4. There we go. All right, so that does number one. That's how I know. Number two, write down the equation that can be represented by graph C. All right, that was g of x. So we're going to write down g of x equals 1 minus x squared. There's our equation. Which part of the equation tells us that the graph opens downward? Okay, which part tells us that it opens downward? They're right here. The negative coefficient. Whenever that lead number in front of the x squared is negative, it's going to open downward like we see in graph C. We've found that out today. We also found that you can make these skinnier and wider by adjusting the number that's in front of them. Like if it's closer to 0, it's going to be wider as a parabola. And as it gets further away from 0, whether it's positive or negative, it makes that rate of change grow faster and it makes it skinnier and kind of closes it in on itself. And we saw that in class today, so that might come up later on. Just thought I'd share that for those that might have been out. Later.